Hello, Sir Rubil. We are from Group 4, and today we will be presenting on Docker, a revolutionary platform that has transformed the way we develop, deploy, and manage applications. So let's dive in. Our team consists of three members, David, Edbert, Santoso, Halim, Nicolas Sugijono, and myself, Anlena, Putri. And in this presentation, we are going to cover a few materials, which are what is Docker, the history of Docker, why do we use Docker, and the key features of Docker. We will be also talking about how Docker works and its architecture, Docker components, practical use cases, and also last but not least, the video tutorial of Docker. So first, what is Docker? Docker is an open source platform designed to automate the deployment of applications in lightweight containers. Containers are portable and include everything an application needs to run, such as code, runtime, libraries, and system tools. Docker ensures that your application will work the same way, no matter where it runs, whether on your laptop, a data center server, or in the cloud. It essentially also decouples the application from the host environment, making it an essential tool for developers and IT professionals alike.
Now, first, I will discuss about the story of Docker. Docker was invented by Solomon Hayes in 2013 during his time at a company called Cloud. The idea originated from the challenges developers face when deploying application across diverse environments. Hayes and his team developed Docker based on Linux containers or LXC, which provided the isolation Docker relies on. Docker quickly gained popularity to its simplicity and efficiency. Within a few years, major companies like Google, Amazon, and Microsoft began integrating Docker into their workflows. Today, Docker is part of the cloud native computing foundation and remains as a cornerstone of modern software. Next, okay. Why do we use Docker? So Docker has several advantages that make it indispensable in the software development lifecycle. First, portability ensures that your application behaves identically across environments. Second, Docker is highly efficient because it uses fewer resources compared to traditional virtual machines. Third, it allows for rapid deployment, helping teams deliver application faster. Fourth, Docker's isolation capabilities prevent conflicts between dependencies of different applications. And finally, it is highly flexible, making it ideal for implementing a microservices architecture. These reasons explain why Docker is a game changer for developers and operations team. Okay, now the key features of Docker. Docker offers several key features that enhance its usability. Its lightweight containers run with minimal overhead, making them fast and efficient. Docker supports multiple platforms, including Windows, macOS, and Linux, ensuring broad compatibility. Networking capabilities allow the containers to communicate with each other seamlessly. Docker also provides version control for containers and images so you can track and roll back changes as needed. Additionally, it also integrates with popular CI/CD tools like Jenkins and GitLab, for example, to streamline the development pipeline. For the orchestration, Docker Swarm help manage and scale containers across multiple nodes.
Okay, now let's get into how Docker actually works. Docker operates using a client-server model. The Docker client sends commands like build and run to the Docker daemon, which builds, runs, and manages containers. Docker Hub acts as a repository for Docker images, enabling developers to share and access pre-built images easily. In essence, Docker streamlines the lifecycle of creating and deploying containerized applications. Now, let's get into the architecture of Docker. Docker architecture has multiple layers. The first one is the client layer. It issues commands to the Docker engine. Then there's the daemon layer that handles container operations, while the registry layer stores Docker images. And at the bottom, there's a host layer that runs containers using the OS kernel. This design ensures efficient and reliable containerization. Next. Okay, now there's the Docker components. Docker has a modular structure with several critical components, each playing a specific role in the containerization ecosystem. Let's get into it. The first one is the Docker engine. This is the core of the Docker, responsible for creating, managing, and running containers. It includes the Docker daemon, which performs backend tasks like building images, running containers, and managing system resources. The engine ensures smooth communication between the Docker client and the host system. The next one, there's a Docker images. These are the blueprints or templates for containers. A Docker image contains everything an application needs to run, including the code, runtime, libraries, and environment variables. Developers can pull pre-built images from the Docker Hub or create custom images using a Docker file. Next, there's the Docker containers itself. The containers are the running instances of Docker images. Think of them as lightweight portable environments where your application lives. They are isolated from each other and the host system, ensuring no conflicts between applications. Containers are fast to start, stop, and replicate, making them ideal for dynamic workloads. Next. Okay. Next one is a Docker file. A Docker file is a text file containing a set of instructions to build a Docker image. It specifies details like the base image, application, dependencies, configuration settings, and commands to run. By using Docker files, teams can automate the creation of consistent images across the environment. Okay, next there's a Docker Compose, where the Docker Compose is a tool designed to handle multi-container applications. Instead of managing individual containers, you can define your application services in a Docker Compose.yml file. With one command, Docker Compose can start or stop all the containers, networks, and volume defined in the file, simplifying complex setups. And the last one is the Docker Hub. This is a cloud-based repository where users can store, share, and access Docker images. It includes both official images maintained by Docker and community-contributed images. The Docker Hub accelerates development by allowing developers to reuse and adapt existing images instead of starting from scratch. Each of these components work together to create a seamless workflow, building, shipping, and running applications. They are designed to simplify development, reduce error, and speed up deployment. Next.
Okay, so last but not least, let's talk about its practical use cases. Docker is used in a variety of scenarios. For example, in web development, it provides isolated environments, ensuring that services like databases and APIs don't conflict. And CI/CD pipelines benefit from Docker's ability to automate testing and deployment. Then we have microservices architecture rely on Docker to deploy and scale individual services independently. Also, in data science, Docker allows researchers to share reproducible environment that includes specific libraries and dependency. Finally, during the cloud migration, Docker simplifies the process by making applications portable across different cloud providers. So, in conclusion, Docker has transformed the way applications are developed, tested, and deployed. By offering portability, efficiency, and scalability, Docker meets the demands of modern software architectures like DevOps and microservices. It allows teams to work faster, reduce the costs, and ensure consistency across many environments. With its fast ecosystem and community support, Docker remains a critical tool for organizations aiming to innovate and stay competitive in this digital age.
Okay, now we are going to the last part, which is the Docker video tutorial. Enjoy.
Hello, Sir Rubil. Now we are going to showcase in this section how to use the Docker. So first thing first, what we need to do is to download the Docker desktop. So I would recommend to go to the docker.com and then try to search for the Docker desktop. And then we will suggest to download the Docker desktop based on the personal computer that we have. Because it is easier to use Docker desktop than not having the Docker installed in our laptop. So we can use either Mac, Windows, or Linux according to the personal computer or the laptop that you have. So once we have already downloaded the Docker, it will shown here, and then we can just run the downloading of the Docker until it is installed. And then once it is installed, we can open the Docker desktop in our desktop. So we can just search for Docker desktop, and then we can double click on the Docker desktop. So here is how the Docker desktop look like. So we have a few components that have been explained by my friend Nicola Sugijono in the presentation. So first we have the container. So container is a place where we can run a container that will pull images. So in this container, we can do a lot of things such as creating images, running Docker files and everything. And then we have the images. These images are the one of the Docker components where we can pull images and then we can use it for API or for deploying applications or all that stuff. So in this presentation or in this demonstration, we are going to demonstrate how to run a container and also pull images. There are also a few other things like volumes, builds, environments, and scout. So volumes is like the way to where we create volumes. The volumes can store data from the containers, or we can also build our own Docker file, build our own environment, and also advanced analysis using Docker Scout. But we are not going to talk about that. We are just going to talk about how to run a container and also pull image in this section. So the way we are going to demonstrate the Docker is through an API called the ngrok. So we have used ngrok before when we want to deploy a model. So for example, as data scientists, we have already created a specific model. And then we want to deploy the model so that the application or the front end and back end can use our model for the deployment of the application. So what we do is we pull images from Docker and then we run the container through ngrok, so that ngrok will create a specific what do you call it, like source or specific API that we can shoot the API from the back end. So in Indonesia we call it like nembak ke API-nya gitu. So when there's the back end, that back end can nembak ke API-nya of the ngrok. So now we are going to show and demonstrate how this works. So first thing first, what we need to do is we need to have the ngrok set up. So we can go to the ngrok, and then we can see here we have the Docker documentation using ngrok. So we can explore ourselves. And then what we need to have is our authentication token. So we can search for ngrok auth token. So we can go to ngrok first, and then we need to log in first. Once we have login, so I have login already in the ngrok here. So that's why I already have my authentication token. So we can just click on the I symbol here so that we can see our authentication token. And then later on, we will use this authentication token to run our API or our ngrok. So we are going to use one of the project that we have created. So this is one of the project in our software engineering course. So first thing first, we need to open the command prompt. And then we are going to, I have written down a few things that we need to do. So first, we need to pull the image first. Why do we pull the image first? Because we want to make sure if the image actually exists and ready or not. So once the image is ready, then we can create the container or we can run the container. So first, let's say we use the template image, like the name is Word Night. So we're just gonna use it for this demonstration. So let's say we are pulling the image. If the image is ready, then Docker will pull and download it first. It should be pulling the layer like this. See, you can see that the Docker works in layer, so it will download one by one. So we can see that we will wait for a few seconds until it is downloaded. So once it is downloaded, it should say pull complete for each of the layer. Okay, so we are just going to wait first until it is fully downloaded. Okay, later on, once it is fully downloaded, we are going to use the Docker run blah blah blah, this code to run our ngrok. So here it says that we need to use our authentication token. So what we need to do is just copy this authentication token, and then we are going to paste it on our auth token. So this is what we need to do. So we are just going to copy this one, and then we are going to paste it here. Okay, so now you see here that we already have our ngrok in our localhost 8080. So we are using the 8080 port. And then once it is already ready, so the ngrok free.app, we can just use this ngrok file, and then we can send it to the backend or also front end. And then they can so we can deploy our model, and then the model can be connected to the backend or front end of our application. So Docker actually cannot work alone. Usually Docker will be used to help a certain application or model to deploy something. So this is like Docker is one of the virtual machines that can collaborate a lot of different things. Yeah, so that is why Docker is very useful when we work with so many different kinds of application softwares and any kinds of purposes. So yeah, I think that's all from us about how to use Docker. And thank you for watching our video. Hopefully this video is helpful. And yeah, once again, thank you, Sir Rubil. And this is it from our team. Thank you.